Okay. So recently, I think I presented at the last meeting, we explored the glutamine and glycine as amino acids, compared it to PET in tumors. We have in Vienna this very high resolution 7 Tesla MRSI method. And now I expanded it to look into glutamate, the neurotransmitter, in the peritumoral region, because research indicates that it's involved into epileptogenicity, cytotoxicity, infiltration, many interesting and horrible things that happen in gliomas. To this end, we looked at our previous data and now defined a peritumoral region that was evaluated as well as the tumor region. We looked primarily at median values of metabolic ratios. If you want to know more, ask me later, no time to explain properly. Dissimilarity coefficients between hotspots and statistical differences between regions. We found several interesting things, like that the ratio of glutamine to glutamate correlates with associated epilepsy, that also glutamate plus glutamine correlates with IDH, that the DSCs are, that's a bit too long to explain probably now. Let's look at this figure here. What we see that the ratios of glutamate to N-acetyl acetate, glutamate to NAA, and choline to NAA all behave differently. So choline, which is a clinically routine marker in spectroscopy, basically is not increased peritumorally. Glutamine is increased a bit, but also increased in the tumor, which we know previously. But glutamate is distinctly different from these in the peritumoral region. So also we have some statistical certainty on that, and to show it in a quick figure, that is actually not the last very long presentation session. So here you would see that highlighted actually that there is some activity with glutamate that you don't see with glutamine, which would be more dark over here. And to come to conclusions, this is a first analysis of this peritumoral glutamate. Could be interesting to show in infiltration for associated epilepsy and in general for metabolic research. I would say it has a high potential, as we have defined today. Spectroscopy always has a high potential. And with MRSI, we can really for the first time investigate this peritumoral region. With single voxel or low resolution methods, you cannot really look at this. So I think pretty sure this is the first time someone looked at this. The limitations are, of course, when the tumors are too deep and enter the regions of B0 inhomogeneities. The cohort size is with 36 not small for MRSI, but also not big for any regular study. And also being reliant to metabolic ratios introduces a lot of uncertainty. We hope that in the future we can go to quantitative metabolic mapping in patients, and this would help a lot more. So with this, I have teased you properly. I will now see myself out with this nice AI-generated cat picture. And I hope you have fun with the next scientific presentations. Ask me later questions about my work. Thanks.